Most people use the internet every day. Messages are sent instantly across continents. Videos stream from servers thousands of kilometers away. Information appears within seconds after search. The experience feels effortless. A simple tap on a screen, a few letters typed into a search bar, a video that begins playing almost immediately. But behind that simplicity lies one of the most complex technological systems ever built. The internet is not a single machine. It is not owned by one company. It is not controlled by one government. It is a vast network of networks, millions of independent devices connected through shared rules that allow them to communicate with one another. To understand how the internet works, it helps to imagine it not as a place, but as a process that moves information from one device to another through countless intermediate systems. Every time a person loads a website, sends a message, or watches a video, data begins a journey. That journey often travels thousands of kilometers in fractions of a second, and it does so through physical infrastructure that most people never see. At the foundation of the internet lies something surprisingly tangible: cables. Vast networks of fiber optic cables stretch beneath cities, across continents, and along the ocean floor. These cables carry pulses of light that encode digital information. The true backbone of the internet lies beneath oceans and underground. Once data enters this physical network, it must navigate its way to the correct destination. This is where routers come into play. Routers are specialized computers designed to direct data traffic. They examine the destination address attached to each piece of data and determine the best path through the network. These paths are not fixed. Routers constantly exchange information with each other about network conditions. If a cable becomes congested or a connection fails, routers dynamically reroute traffic through alternative paths. This ability to adapt is one of the reasons the internet is so resilient. Even when parts of the network fail, communication can continue through different routes. But before data can travel across the internet, it must first be prepared for the journey. Large pieces of information are broken into smaller units known as packets. Each packet contains a portion of the original data along with addressing information. That tells routers where the packet should go. Instead of sending one large block of information, the internet sends thousands of tiny packets independently. These packets may travel along completely different paths through the network. When they reach their destination, they are reassembled in the correct order to recreate the original message, image, or video. This method allows the network to move information efficiently and flexibly. If some packets are delayed or lost, they can be retransmitted without affecting the entire transmission. The system responsible for managing this process is known as the Transmission Control Protocol and the Internet Protocol. Together they form the foundation of Internet communication. Internet Protocol, often called IP, is responsible for addressing. Every device connected to the Internet receives a unique numerical identifier known as an IP address. This address functions similarly to a postal address. It allows data to be directed to the correct destination. However, humans rarely interact with IP addresses directly. Instead, they use domain names. Names like websites, search engines, or streaming platforms. These names are easier to remember than numerical addresses. When someone types a domain name into a browser, a system called the Domain Name System translates that name into the corresponding IP address. This process happens extremely quickly, usually in a fraction of a second. Once the IP address is identified, the request begins traveling across the network toward the server hosting the desired information. Servers are powerful computers designed to store and deliver data. Large organizations often operate massive data centers, containing thousands of servers working together. These facilities consume significant amounts of electricity and require advanced cooling systems to prevent overheating. Inside these data centers, information is stored, processed, and transmitted continuously. Instead of retrieving data from a distant server, users receive information from a nearby server. This reduces latency and speeds up delivery. Caching systems also store frequently requested data closer to users. Further improving efficiency, these optimizations allow the internet to handle billions of simultaneous interactions every day. However, speed and connectivity are only part of the story. Security is equally important. When data travels across public networks, it can potentially be intercepted. To protect sensitive information, encryption is used. Encryption transforms readable data into coded information that can only be interpreted by the intended recipient. Secure internet connections rely on cryptographic protocols that verify the identity of websites and protect data from unauthorized access. These protocols enable secure online banking, private messaging, and confidential communication. Without them, the modern digital economy would not function. As the internet has expanded, new challenges have emerged. The scale of global connectivity means that failures can have widespread consequences. A damaged undersea cable can disrupt communication between regions. A misconfigured router can affect traffic across multiple networks. Cyberattacks can target infrastructure, attempting to disrupt services or steal data. To address these risks, organizations around the world coordinate to maintain and protect internet infrastructure. Network operators share information about outages and threats. Engineers continuously improve protocols to enhance reliability and security. Despite its complexity, the internet remains remarkably resilient. Its decentralized design allows it to continue functioning even when parts of the system fail. No single entity controls the entire network. Instead, it operates through cooperation among thousands of independent organizations. Internet service providers connect homes and businesses. Backbone providers manage long-distance infrastructure. Content providers host websites and applications. Standards organizations develop the protocols that allow all these systems to communicate. Together they form an ecosystem that supports global connectivity. The internet has transformed communication, commerce, education, and culture.